Alright, in this video I'm going to teach you how to use the data analysis tool pack in Microsoft Excel to estimate a regression. The regression we're going to look at is one that's indicated here on our slides, where the model itself is going to use wages for a set of individuals as a dependent variable. That's our y variable. That's the variable we are trying to explain. And to explain it, we're going to use an intercept parameter, a slope parameter, and the age of the individual. The idea behind this regression is that we know that as people get older, they typically develop more experience in a particular field and their wages increase. So if we think this model does a good job at all, we would expect to see a positive intercept for wages, perhaps, and a positive slope. That is, beta 1 should be greater than 0, indicating that as age goes up by 1 year, wages go up by beta 1 units. And that beta 1 will be in whatever units our wages are in. So if you take a look at the salary Excel spreadsheet here, we have a set of 23 individuals. We have the age of those individuals, and we have their salary, or as I've indicated it on the previous set of slides, their wage. Well, to run a regression in Microsoft Excel is actually pretty simple. Once you know what your data are, and we know which our y variable is, so I'm going to put y right here above salary, and above age I'm going to put x, I can just go to the Data tab and then the Data Analysis Tool Pack. And if I scroll all the way down to the bottom, I'll see the option that says Regression. Once I've got Regression selected, I'm going to hit OK. And then it's just going to ask me what variable is your dependent variable, that is the variable you're trying to explain, and which one is your x variable, that is what variable are you going to use to try and explain it. I'm going to go ahead and indicate that I have labels in the first row. This confidence level is set for alpha of 0.05 to do hypothesis tests, and we'll talk about that shortly. And we're going to go ahead and put this output range somewhere on our spreadsheet so that it's useful. I'm just going to put it here in cell I11 and hit OK. All right, when running this regression, we're going to see a lot of new information that we haven't seen before. But we're going to go through and discuss it. First things first, we're going to look at our coefficients in our regression. Those are our estimated parameters, beta 0 hat and beta 1 hat. And what we can do is take a look at these estimated coefficients. Now our intercept here, I'm going to write beta 0, and this is beta 1. And really this is beta 1 hat. That is to say, this is the estimated relationship between age and wage. And as I look at these coefficients, the way I would interpret this is to say my intercept, or my average starting wage, or salary here, should be 8.19. Presuming this is in dollars per hour, this would be $8.19 per hour as a starting wage. And then the coefficient beta 1 here, or the effect of age on my wages, is 1.447, or $1.45 per year old I am. Okay, so every year older I get, I earn an additional $1.44. Now, these are just our estimated parameters, and they're useful for writing out the equation to this line. So if we were to look at this equation, this would tell me my predicted wage is beta 0 plus beta 1 times age. And so what I'm going to do here is I'm going to put y hat right next to my data so that I can generate a predicted wage. Now, our predicted wage, as we saw on that previous slide, should be equal to beta 0, which is our intercept, plus beta 1 times the age of the individual. So for each one of these individuals, we can come up with a predicted wage. All right, so I'm just going to format this quickly in dollars so that we can compare it to the wage here. Now notice for everybody this is not going to be perfect. We're going to have an error term in here that's going to mean for some people we have overestimated their wage. That is, for Mary, given her age, we would expect a salary of $41.48, but she's only making $28.60. For Frida, we've hit it almost exactly on. It says she should be making $53.06, when in fact we see her making $53.30. And so for some people, we're going to have overestimated this wage, like Judd down here. We're going to say he's going to make $70.43, and he only makes $60.20. For some people, it'll go the opposite direction as well. Ellen, she makes $79.80. We would have predicted, given this linear relationship, that she would make only $71.87. So the point of a regression here is to break down with a set of data the relationship between two variables x and y, so that we can generate predictions about what y should look like for any arbitrary value of age. Well, we can go one step further than that and recognize that because these are estimated parameters, that is, they are not the true population parameters beta 0 and beta 1, they are dependent on the sample of data we actually observed. And because they're dependent on the sample, that makes them random variables, which means we can perform hypothesis tests and ask whether or not beta 0 or beta 1 takes on a particular value, just like we would have if we were testing for whether our true population mean took on a particular value. Well, Excel actually defaults to running a hypothesis test for us, and it will always test this hypothesis. It will test, is beta 1 equal to 0? That is the effect of age on my earnings 0? In other words, is it possible that age doesn't matter at all for determining my salary? Well, we could go through and actually work out our hypothesis test by calculating a test statistic. Your lecture notes will show you how to do that. But in short, once we've calculated that test statistic, which we could do manually, Excel will actually do it here for us. We would compare that test statistic to a critical value and then either reject or fail to reject a null hypothesis. That test statistic is given to us right here. We could also take a look at a p-value, which is already calculated for us, assuming that we're testing whether or not beta 1 is exactly equal to 0. Now, I'm going to make these p-values into percentage terms and make them a little bit bigger so that we can see what they say. But notice that the p-value here for the coefficient age is 0. That means we can reject the null hypothesis that age does not matter when determining your salary with 99.999% confidence. However, if we were to take a look at the p-value corresponding to our intercept, or beta 0, that p-value is bigger than every conventional level of alpha we would analyze. What that means for us is that the intercept parameter, or beta 0 hat, doesn't have any real statistical meaning. That is, this is imprecisely estimated enough that we cannot say that the average earnings are any different from 0. Having said that, our best guess though, notice that our beta 0 hats are just like a sample average in that they're an unbiased estimator. So this is still going to be our best guess for the intercept, for our starting salary, without taking into account the age at all. But we can't reject the possibility that there's actually a $0 per hour starting salary. For a lot of these regressions, it's going to boil down to figuring out which of your variables should be your y variable, which should be your x variable, running your regression, and then doing two things. One, being able to read these coefficients so that we know how to interpret them. Okay, so again, we can interpret the intercept here as the starting wage when the age of an individual is 0. We can interpret beta 1 hat as the effect age has on my hourly wage. Once we've got the interpretation down, we can come over here and evaluate a hypothesis test, which indicates for us whether or not we would reject a hypothesis that the coefficient of interest is actually 0. You'll have an opportunity to do many more of these regressions on your homework and in practice problems, but this is how you can work through a basic one here using Microsoft Excel.